Welcome students to Navin Sir Physics classes. In this lecture, we are going to discuss about product of vectors. In last lectures, we completed addition of vectors and we also did some numericals based on addition of vectors. So in this lecture, we are going to deal with product of vectors. So how can we multiply the two vectors? Let us discuss. So here two types of multiplication of vectors are there. So one is scalar product, this is also known to be dot product. And next second one is vector product. Vector product or cross product. Sir, what is mean by scalar product and what is mean by vector product? So both are multiplication of vectors only. For suppose two vectors are given to you, A bar and B bar. Okay, if these two vectors are multiplied, A bar is multiplied with B bar, then if we got the resultant as scalar, then it is known to be scalar product. If A multiplied with B bar, if the resultant is a vector, then it is known to be vector product. So vector product is nothing but if the resultant of multiplication of two vectors is also a vector. That means vector multiplied with a vector. Vector 1, vector 2, we are going to get another vector. So this is vector product. And if vector 1 is multiplied with vector 2, if the resultant is a scalar, then it is known to be a scalar product. Let us discuss in detail what is meant by scalar product. Scalar product. I told you that if the resultant of multiplication of two vectors is a scalar, then it is scalar product. Right. So scalar product, sir, how can we represent a scalar product? So we are not representing as a general multiplication symbol, we are using to represent the product of the two vectors which gives a resultant scalar with a dot. This is dot. So we can pronounce it as A bar dot B bar equals to C, not C bar, because it is a scalar. A and B bar are two vectors. Okay, let us take, if A bar is a vector and b bar is another vector. The angle between two vectors is theta. Then the initial point is same for two vectors a bar and b bar. I am drawing a projection. So projection nothing but it is a perpendicular length of vector b on vector a. So this, for suppose I am taking L. So this L, how can we write from this right angle triangle? So L is equals to, we can write B cos theta, because this is adjacent side. This projection adjacent side we can write cos theta is equals to L by B bar. So we are going to get L is equals to B cos theta. So the product of vector A and the component of vector B we can represent as A bar dot B bar. That is the resultant of A bar dot B bar. So simply the dot product between any two vectors, if it is P bar cross P bar dot Q bar, R bar dot S bar, whatever it may be, we can represent as AB cos theta, or if we take two vectors as PQ cos theta, PQ and PQ cos theta, you are going to get. Sir, what is here B cos theta? Here B cos theta is the component of vector B on A. Again, the length of B, the projection of B on vector A is known to be component. So component of vector B is equals to B cos theta. Therefore, we can represent A bar dot B bar as AB cos theta. This AB cos theta is a scalar. Okay. Let us get into some more in detail explanation of that. So we know that A bar dot B bar is equals to AB cos theta. So if theta is given, for suppose they are asking what is the angle between the vectors. So we can find angle between the vectors A bar dot B bar by AB. Sir, what are AB here? A and B are magnitudes of vectors A bar and B bar. Okay, with this value we are going to find out what is the angle between them if A bar and B bar is given. And in the same way, in rectangular components, so how can we write the dot product between them? So before going to discuss that, let us discuss some properties of scalar product. Okay, right. So scalar product, it obeys law of commutative. So we know that what is meant by commutative law. A bar dot B bar is equals to B bar dot A bar. And next, it obeys distributive law. Over addition. That is A bar dot of B bar plus C bar is equals to A bar dot B bar a bar dot c bar we can write. In the same way, if the angle between two vectors is 0 degree, then a bar dot b bar equals to ab cos 0 is 1, then dot product between them is maximum. Next, if two vectors are perpendicular to each other, that is a bar dot b bar is equals to ab cos 90. So cos 90 value 0, therefore the total term will be 0. That means the dot product between two vectors is 0 when they are perpendicular to each other. So in this first case, the two vectors are in the same direction, a bar b bar in the same direction. And what is second case? A bar is perpendicular to b bar. If a bar is perpendicular to b bar, then the dot product between them is a null vector. So 0 resultant. And next, if two vectors are anti-parallel, that means they are opposite vectors. If they are opposite vectors, the angle between them theta is equals to 180. If theta equals to 180, we can write a bar dot b bar is equals to ab cos 180. So cos 180 value minus 1, therefore a bar dot b bar is equals to minus 1. That means the dot product between two vectors can be positive, 0, negative. Okay, so these are the some properties related to this. Now let us take some more applications based on this. Right, we know that the dot product between the vectors which are perpendicular to each other gives a null vector. Let us find out the dot product between the unit vectors I, j, k. We know that I is the unit vector along x-axis, j is the unit vector along y-axis, k is the unit vector along z-axis. So what is the angle between I, j, k? I, j, k are mutually perpendicular. Okay, let us write I bar dot I bar. So mod I, because a bar cross b bar, mod a mod b into cos theta. So if you take another vector along x-axis, that also in the same direction. That means what is the angle between I and I? Theta equals to 0. So magnitude of I is 1, I1 cos 0. Cos 0 value is 1. So product between I dot I is 1. Similarly, j bar dot j bar or j cap dot j cap, we can write j cos 0. So cos 0 is 1. So we are going to get k bar dot k bar is also equals to 1. That means the dot product between parallel vectors is equals to, that means I dot I, j dot j, k dot k is equals to 1. It's a very important result we are using in multiplying the two vectors. Right, next, Let us find out I bar dot j bar. Okay, so I bar dot j bar. So I mod j cos theta. So I and j are perpendicular vectors. So theta 90. So cos 90 is 0. That means I bar dot j bar is 0. In similar manner, j bar dot k bar is also 0. K bar dot I bar is also 0. That means these two vectors ij, jk, ki are perpendicular vectors, or they are also known to be orthogonal vectors. The dot product between orthogonal vectors or two perpendicular vectors is always gives a null vector. Okay, it is also a very good result, so which we are using in multiplication of the two vectors. Right. Now multiplication of vectors in rectangular components. Okay, two vectors are given. If a bar equals to the given that axi, ayj, azk, and b bar is equals to bxi, byj plus bzk. They are asking find a bar dot b bar. So how to find the dot product between them? They didn't give any angle here, so they gave the rectangular components. So let us do this. A bar dot b bar. So axi, ayj, azk dot bxi, byj plus bzk. So multiply this ax bx I dot I plus ax by I dot j ax bz I dot k ay bx j dot I ay by j dot j plus ay bz j dot k plus az bx k dot I az by k dot j az bz k dot k. If you observe this expression carefully, so I dot I is 1, j dot j 0, I dot k 0, j dot I 0, j dot j 1, j dot k 0, k dot I 0, k dot j 0, and here 1. So where we have the product between the parallel vector, that terms only left. Rest of all the quantities are going to be 0. So what are left here? This will be left into 1 ax bx. Next plus the rest of two terms will be 0, and then ay by and then az bz. So this gives the dot product between the two vectors in rectangular components. In rectangular components, if they mention directly, We can take ax, bx, ay, by, az, bz. Let us take one example here. So two vectors are given 2i minus j plus 3k dot 4i plus 2j minus k. So they are asking dot product. So directly we can find ax, bx, 8, ay is 1, by is 2, minus 2, az, bz, so minus 3. So 8 minus 5. So your answer is 3. In this way we can find out dot product between the given two vectors in rectangular components. Right, let us see some examples. So where we can get this kind of product in our physics. So work done. Work done is a what kind of quantity? Work done is a scalar. So how can we get work done? We know that work done is the product between force and displacement. So in force is a vector, displacement is also a vector. That means we are multiplying the two vectors to get a resultant as work. So work is what kind of quantity? Scalar quantity. But here we are getting the work done from where? Due to multiplication of two vectors. So for suppose an object of mass m is applied by a force of 5 Newton. The angle between force is, for suppose force is 5 Newton and displacement is s is 5 meter. The angle between theta is given as 60 degree. They are asking find the work done in this case. So it is dot product. Now can we apply W is equals to Fs cos theta. So magnitudes are given 5 into cos 60 1 by 2. So therefore what we are going to get 12.5 joules is the work done. Okay, na? That means work done is a scalar quantity. If the force vector, displacement vector is given, if they are asking work done, we can approach with a scalar product. And then power. Power is also a scalar quantity. If force vector and velocity vector is given, if they are asking power, to find power we can take the dot product between force and velocity vector. In the same way, in a case of a energy, so when, let us imagine, in a magnetic field a bar magnet is located. So when a bar magnet is located, it has some energy in the magnetic field. So B bar is the magnetic field, M bar is the magnetic moment. So the potential energy or energy stored in a magnet or potential energy of a magnet in a magnetic field, we can write u equals to minus m bar dot b bar. Here m bar is magnetic moment. We discussed in the chapter units and dimension what is meant by magnetic moment, and b bar is magnetic field strength. And then in the similar manner, when an electric dipole, so electric field and a dipole, electric dipole, positive and negative, if it is placed in, it is also have some energy, that energy minus p bar dot e bar. where P bar is dipole moment, electric dipole moment, and E bar is electric field vector. So these are some examples for scalar product we can come across in physics. Okay, right? Let us take one example here. The given like this: A bar is equals to 2i minus j plus ck, and B bar equals to 2i plus 3j minus 4k. If A bar and B bar perpendicular vectors, find C. So they given hint as perpendicular vectors. If they are perpendicular vectors, dot product between them is 0. Okay, so do it. 2i minus j plus ck dot 2i plus 3j minus 4k, we should equal with 0. So I told you that only component should be multiplied. 4 minus 3 minus 4c equals to 0. Therefore 1 is equals to 4c, therefore c equals to 1 by 4. So in this way we can get a problem based on this. Next, one more example we'll take. A force of F bar equals to 6i minus 2j plus k acts on a body causes a displacement minus 2i plus j plus 4k. Find work done by force. Force vector given, displacement vector given. They are asking work done. We know that work done is a dot product between force vector and displacement vector. So do it. 6i minus 2j plus k dot minus 2i plus j plus 4k. Okay, let us multiply the components here. Minus 12 minus 2 plus 4, so minus 10 joules is the work done by the force in displacing the body. And another way also we can expect a question from this. So they are going to ask by giving the vectors. So A bar is given as I plus j plus k. B bar is given as 2i minus j plus 2k. Now they are asking find the angle between A bar and B bar. Okay, so I am going to use A bar dot B bar is equals to AB cos theta. Okay, so A is nothing but what? Magnitude of vector A. B is magnitude of vector B. I am calculating magnitude of vector A as under root of 1 square plus 1 square ax square plus ay square plus az square root 3 is A, and then similarly under root of 2 square 1 square plus 2 square. So 4, 4, 8, 3. B is 3. Next, A bar dot B bar, because cos theta we can express A bar dot B bar by AB. So A bar dot B bar, I plus J plus K dot 2I minus J plus 2K. So multiply the components, 2 minus 1 plus 2. So 3. Okay, now let's substitute here cos theta equals to 3 by 3 root 3. So cos theta is equals to 1 by root 3. Therefore theta is equals to cos inverse of 1 by root 3. So in this way we can expect a question from the dot product of the vectors. Okay, so dot product of the vectors is nothing but what? It is the product between the two vectors in which we can get a resultant as a scalar. So A bar dot B bar we can represent as AB cos theta. Theta, where theta is nothing but angle between the two vectors, and B cos theta nothing but the component of the vector. Okay, stay safe, take care.